So actually we are given a question, rotate image, lead code question basically. So the question is we are giving n into n 2D matrix representing which basically represent the image. Now we have to rotate the image by 90 degrees clockwise direction. So basically what we have to do, we are given a matrix and we have to rotate it by 90-degree clockwise and it will look like this. Okay, so let me take to the board. Now when I take the matrix as a whole, suppose this is a container, and when I rotate it with 90-degree towards this direction, 90-degree, and what it will look like, actually eventually it will look like this, 1 2 3. Basically this will come here, है so and this will go there. Okay, so 90-degree we are turning to 7 8 9. Okay, and 1 2 3 like this, 7 and 8 9 and 4 5 6. So basically the output array will something look like this. So this is what we are required, we want to return, and this is the answer. And similarly for this, now the what is the intuition or how to approach this question, this standard array question. Okay, so now let me write it again in a small manner that it should 7 8 9 4 5 6 1 2 3. So basically what we are doing basically here, if this is a matrix now, so if I find the transpose of this matrix, so the intuition is something like this. If I transpose the matrix, which means in transpose the rows, this is basically a row and this is basically a column and this is a row. So in transpose, row will become column and column will become row. Basically row and column are interchanged, row and column are interchanged with each other. So this row will now become column 1 2 3. This row will become column 4, 5, and 6. This row will become column 7 and 8 and 9. And vice versa, we can see as this row will become column. So this column will become row 147, 147. Okay, now to reach from the here to here, we can observe that if I reverse the each row, if I just simply reverse the each row, I will be there. Okay, so 147 will be 7 4 1 8 5 and 2 and 9 6 3, which is exactly same as this. Okay, so first what I'll do, I'll first find the transpose, and then in another function using the reverse function, I'll reverse each row and then return it. Basically we don't have to return anything because the question says we have to rotate the matrix in place, not making a new array and then returning it. Basically we have to make the changes in this. So we will use the same matrix, first find the transpose, then reverse each row, and answer will be here. So now let derive the algorithm and how to find the transpose basically for this. Okay, let me erase fast. Okay, so now if I write the column number here and also here. Okay, yeah. So basically, I'll write the column number here 0, 1, 2, 0, 1, and 2. So basically, these are row number and column number. Basically, they are indices. So 0, 1, 2, 0, 1, 2. If I carefully observe that one is here only, one is here in the transpose matrix. If I compare both of these matrices, I'll find the location, that how they are basically actually changing their location. Okay, so now if I write the first row, basically 1, 2, and 3, and 0 here, 1, 2, sorry, and 0, 1, and 2. Now, if I check 0, comma 0 satisfies, 0, comma 0 satisfies. Now here 2 and here is 4. So let's write the index of 2. So the index of 2 is 0, comma 1, basically 2. So in place of 2, we are actually writing 4. Okay, so 4 is where in this matrix it is at 1, comma 0. So the 4 index is 1, comma 0. So this is the pattern. Basically, we are just reversing the I and j and then swapping it. So basically, 1 is replaced with the swapped with 4, and if I'll now take suppose 3, so 3, if I'll take 3, so 3's index is 0, comma 2. So according to the algorithm that I and j are being swapped, so 2 comma 0 will be at in this position. Okay, so 2 comma 0 is 7 and 7 is in this position. Okay, so this is the one. Now, if I'll just erase this part, okay, so now this matrix is made initially using this logic when we are traversing the first row. Now, when we are at the second row, we don't have to touch the first element, because in this question we are doing it in place. So if we touch the first element, it will be actually 2, not 4 now, because we are doing in place, not to a new matrix. Okay, so I'll start from, so when in this case I equals to 0 and j is also equals to 0, basically if we consider I and j. So when I equals to 1, so basically we have to start in this row from here, not from 4, because this is the left, because this is the same. So when I traverse this will be replaced with this. So this index is 1, comma 2. 1, comma 2 is replaced with the 2, comma 1. So 6 is replaced with 8, so we get 8 here and 6 here. Now when I am the second row, I have to start from here. So basically at every row we are traversing it from where, from its row number only. So basically if I equals to 1, j is also equals to 1. If I equals to 2, then j should also be starting with 2, because if I equals to, if we are at this row, we must be starting at this row, this element and this cell. And if I equals to 1, basically row number, then we also start have to j with this only. I equals to 1 and j equals to 1 and same. So at last 9 will stay here. Now this matrix is the matrix is got transpose is this. Okay, now what I have to simply do, I basically have to just reverse the each row using the reverse function. So it will be 7, 4, 1, 8, 5, 2, and 9, 6, and 3, and this is the answer we require. Okay, so now let's discuss its time complexity. So the time complexity of this question will be order of n square, as we are traversing almost the, not basically it will be n into n minus 1. Basically for every n we are traversing n minus 1. So n minus 1 will always be, in worst case it is n square. And if I calculate, okay, so since we are doing it in place, so the space complexity will be constant, that is O of 1. So now let's code. If I go to the question, we are giving a void, basically a non-return function. So what I'll do, basically, first I have to just grab it, n equals to matrix dot size to just to traverse, and this is the n into n matrix, so we don't care for column. So initially what I was doing, I was just making the matrix transpose. So first I was making the matrix transpose, that is if for int I equals to 0, I less than n, I plus. Now when I said that I said that if I equals to basically 1, then j should also be 1. So basically at every row, the column we are traversing, I and j must be equal basically. Okay, so for int j will start from basically I, j less than n, j plus plus, because it's a square matrix, and we will swap matrix, basically matrix of I comma j with matrix of j comma I. Okay, now the now we got the transpose matrix. This loop basically make the matrix transpose. Okay, now what I have to do, I'll just have to reverse each row of matrix. Now what I'll do, I'll just traverse from I equals to 0, I less than n, I plus plus, and I'll just reverse using the function this, that matrix of I dot begin. This is the iterator to the first row of the end up till matrix I dot end. So I have to reverse, and when I'll submit run this, it will actually run fine. And yes, it is running fine. Now let's try to submit the solution. And yes, it is running exactly fine, and we